New topic, moving charges and magnetism. So here first problem. The magnetic induction at a point P, which is at a distance of 4 centimeters from a long current carrying wire, is 10 power minus 3. So this is a long current carrying wire, infinitely length, and at a distance of 4 centimeters, the magnetic field is 10 power minus 3 Tesla. The field induction at a distance of 12 centimeters from the current carrying wire. So from here, at 12 centimeter distance, what is the field? That is B2, how much? Now, magnetic field due to a straight current carrying conductor of infinite length is given by mu naught I by 2 pi r. So in this case, mu naught current 2 pi constants. So B inversely proportional to distance. So we can write B1 by B2 is equal R2 by R1. B1 is 10 power minus 3. B2 we are finding R2 12, R1 4, 4 1s so 4 3s. So B2 will be 1 by 3 into 10 power minus 3, 0.11 into 10 power minus 3, 1.11 into 10 power minus 4. Option 2 is correct. Two infinitely long straight conductors which are held parallel to each other at a distance of 0.4 carry currents 20 amperes and 10 amperes in the same direction. The magnetic induction at a point midway between them. So this is the first wire which is carrying a current of 20 amperes. This is another wire which is carrying a current of 10 amperes. The distance between these two is 0.4 meters. So the magnetic field induction is the midpoint between these two. So here I want to find out magnetic field. Remember, by using Ampere's right hand thumb rule, when the current is flowing in this direction, field here due to this first wire will be inside. So B1 will be inside this, and here for this current B2 will be outside. So at this point we have two fields which are acting in opposite directions. So what is the net field here? B net is given by, as this current is more, we can say B1 greater than B2. So this is B1 minus B2. B1 we know due to a straight conductor mu naught I by 2 pi r, and for a circular coil mu naught Ni by 2 r. Be careful with these two formulas. Now B1 will be mu naught I1 by 2 pi r minus mu naught I by 2 pi r, because this distance and this distance both are same. So here r is equal to 0.2. So now we can write mu naught by 2 pi r common I1 minus I2. Mu naught value 4 pi into 10 power minus 7. 2 pi into 0.2. So let me write 2 pi into 0.2. This is difference between two currents, 20 and 10. This is 20 minus 10. So 2 pi 1, so 2 pi 2s. So this will be 0.21, so 0.2, 10. So this will become 10 power minus 6. So 10 into 10 power minus 6. Or you can write this as 10 power minus 5 Tesla. Option 1 is correct. Two long straight conductors held parallel to each other at a distance of 0.3 meter. If the conductors carry current 2 and 8 amperes in opposite direction, this is 2 amperes, let us say this is 8 amperes, but in opposite directions, that means it is flowing down. Now, the distance of the neutral point from the conductor carrying smaller current. Always the neutral point will be formed away from the system if these two are carrying current in opposite direction. If they are carrying current in same direction, neutral point will be formed between the conductors. For opposite direction, neutral point will be formed away from this one. Let us say this distance is x, and now at this point, this current which is carrying 2 amperes current will produce field outside. So this is B due to 2 amperes which is outside. But what about this current? Due to this 8 amperes, field here will be inside. So B due to 8 amperes current will be inside. As these two are acting opposite to each other, net electric field may become 0. So let us say at this point net electric field is 0. So let me take this point as neutral point. At n, point n, B due to 2 amperes current is equivalent opposite to the B due to 8 amperes current. So what is the B due to 2 amperes current here? Mu naught I is equal to 2 pi x is equal, due to 8 amperes, mu naught into 8 by 2 pi into 0.3 plus x. This is 0.3 plus x. mu naught get cancelled, 2 ones, 2 fours. This 2 pi get cancelled, 4 into x. 4x is equal 0.3 plus x. If it comes this side, 3x is equal to 0.3 and x is equal to 0.1 meters. So this is the distance of the nodal point from the conductor carrying small current. But in the same problem, sometimes they may ask us to find out nodal point from the bigger current, that is carrying bigger current. So this will be 0.3 plus this is 1.4. 0.4 will be the answer, but in this problem this is only option 4 is correct. A long straight conductor carrying a current of 10 amperes is upward is held vertically. That means it is held vertically upwards like this. If the BH is 4 into 10 minus 5 Weber per meter square, then distance of nodal point from the conductor is. So when it is carrying current vertically upwards, the field will act in this direction on the left and in this direction to its left, and this is right. But here I cannot draw a diagram like this. So let me draw. This is the conductor which is carrying current vertically upwards. So as the current is coming like this in this direction, here field will be in this direction. So this is the magnetic field due to this straight current carrying conductor. So here let me take, this is north, this is east, this is south and west. If the BH value is 4 into 10 minus 5, BH is the horizontal component of earth magnetic field which always acts from south to north. Here BH will also act in this direction. Here field due to wire and field due to earth are acting in the same direction. So net field cannot become 0. But what about this field here on the left side of it? Here B is acting downwards at this particular point and BH is acting upwards. So here these two will be equal and opposite. So what is the distance of the nodal point? This distance they are asking from the wire. So here at this point, let us say this is the nodal point at N. B is equal to BH and B is equal to mu naught I by 2 pi r is equal to BH is equal to 4 into 10 power minus 5. Mu naught is equal to 4 pi into 10 power minus 7. The amount of current flowing through this one is 10 amperes by 2 pi r we are finding here. This will be 4 into 10 power minus 5. 2 pi 1 so 2 pi 2's. This will be 2 into 10 power minus 6 by r is equal 4 into 10 power minus 5, 2 ones and 2 twos. So r value will be 10 power minus 6 by 2 into 10 power minus 5, 1 by 2 into 10 power minus 1. So this will be 1 by 20, 1 by 2 is 0.5, 1 by 20 is 0.05 meters. So answer is 0.05, but if you see the options, this is 0.05 and 0.05 towards west or east. Here, after observing this one, this is west. From this conductor, this point is on the west side. So this is towards west. So the answer is 1. A current of 1 ampere is flowing through the sides of an equal triangle of side. This is an equal triangle of side 3 into 10 power minus 2. Current is flowing through this one. This current is 1 ampere. The magnetic field at the centroid of the triangle. So here I want to find out the magnetic field at the center of this triangle. The side is 3 terminus to meter, or we can write 3 centimeter. So now what is the distance of this one? We can say this is 60, this will be 30. And what is the distance of this one? I can write this as sine 30. Otherwise, let me take this as r. For this I want opposite side and I know the adjacent side. So let me take tan 30 is equal r by half of this. This is 3 centimeters. So 1.5 centimeters, that is 1.5 minus 2. Tan 30 1 by root 3 is equal to r by 1.5 minus 2. R is equal to 1.5 by root 3 into 10 power minus 2. So this is r value. So let me find out magnetic field due to one side. So magnetic field due to one side of the triangle, mu naught I by 4 pi r sin alpha plus sin beta. So where this is alpha and the other side it will make an angle beta here. This is r. Now, so this will be 4.7. So 10 power minus 7 I by r, because 4 pi, and otherwise let me write this is 4 pi, this is 4 pi, 4 pi cancel. I value current is 1 ampere. into alpha. We know that this is 30, this is 90, it must be 60, and alpha and beta are same. This is sine 60 plus sine 60. So this will be 10 power minus 7. What is R value? 1.5 by root 3 into 10 power minus 2. Sine 60 root 3 by 2, root 3 by 2. That is root 3 only. So root 3 into root 3 will be 3. So 3 into 10 power minus 5 by 1.52. So this is 2 into 10 power minus 5. This is magnetic field due to one side. Here if the current is flowing like this, the field is outwards. Here this is field is outwards, and here also field at the center is outwards. So all these three sides will produce magnetic field at this center which are acting outwards. So the net magnetic field at the center of this centroid of this triangle is given by 3 times the magnetic field due to the side. Each side 2 into 10 minus side. So 3 into 10 minus means this will be 6 into 10 power minus 5 Tesla. So option 4 is correct. Two circular coils of radius 10 and 30. This is R1, this is R2. Having same number of turns are connected in series to a battery. So this is the first coil, and this is the second coil. Both are connected in series to a battery. Now the ratio of the magnetic inductions at the center of these two coils, this is first one and this is the second one. So they are asking what is B1 by B2. Magnetic field due to a circular coil is mu naught Ni by 2R. So here, as both are connected to the same cell, so same current, as these are connected in series, same amount of current will pass through these two. That is I1 is equal to I2. So mu naught N1 I1 by 2R1 by B2 will be mu naught N2 I by 2R2. That is 2R2 by mu naught N2 I2. Here 2 and 2 get cancelled, mu naught and mu naught get cancelled, and they are having same number of turns, mentioned here same number of turns. So N1 N2 also cancels, and the I1 and I2 also same. So this is R2 by R1. R2 will be 30, R1 is 10. So option is 3:1. So don't go for 1:3. Answer is 3:1. The magnetic induction at the center of a circular coil carrying current is B. If the coil is rewound to have thrice the number of turns, the same current is passed with the magnetic field. Magnetic field due to a current carrying coil is mu naught Ni by 2R. Here the number of turns are tripled. So if but means radius is not mentioned. So what we have to write? B directly proportional to N by R, because all other coils are same. If a coil is rewound like this, that means if radius increased, here number of turns will be more and number of turns will be less. But if a coil is like this, whose radius is R and number of turns are N, if it is rewound to thrice the number of this one, the radius will be reduced by R by 3, because the product of these two must be same, because length of this wire is 2 pi R for one circle into N. This is the total length of wire. So here 2 pi is constant, that is L directly proportional to R into N. If N is tripled, R will be 1/3. So here in this case, B1 by B2 is equal N1 by R1, R2 by N2. So N1 is N, R1 is R. N2 is 3N, R2 will be R by 3. That we have to remember here. N and R get cancelled, 1 by 9. So B1 by B2 is equal to 1 by 9. So B1 is B by B2 is 1 by 9. So B2 is equal to 9B. So magnetic induction at point P is here. This is infinitely long wire which is bent in the form of a circle at midpoint. So what is the magnetic field at this point? The radius is R. So here current will flow like this, and then it will go like this. It will move in a circular path and then it will go up. What is the magnetic field due to a straight current carrying conductor of infinite length? For infinite length, current I at a distance R, this will be B is equal to mu naught I by 4 pi R into sine alpha plus sine beta. This is the formula. But if infinite length, alpha will be 90, beta will be 90. So due to this is actual formula, general formula for any wire, straight wire. For infinite wire, this will become sine 90 plus sine 90, 1 plus 1, 2. 2 to get cancelled, mu naught I by 2 pi R. This is for infinite length. Now For finite length, let us say distance is r. Here this is alpha, this is beta. Then this will become b due to finite length. This will be the same formula, sin alpha plus sin beta. But if one of the end is here, if you know the one of the end, the other end is infinite, then alpha will be 90, beta will be 0. So b at the end of this wire will be mu naught I by 4 pi r sin 90 plus sin 0. This will be 1. So this will be the formula. Now here, if you see this one, this is infinite wire, and we are finding magnetic field here at distance r. So do this infinite wire at distance r, this will be 90 and 90. So infinite wire, let me take this formula mu naught I by 2 pi r. Now due to this circular coil, B due to coil, this is mu naught I by 2r, because there is only one turn, n is equal to 1. Now what are the directions of this B coil and B wire? B due to wire is here mu naught I by 2 pi r. For this straight current, this is the current, this is the field which is acting outside. So this is acting out. But for this circular coil, as the current is flowing in this one, field is into, this is into. So one field is acting outwards, one field is acting into. This is outwards, this is into. So what is the net field? The net field is given by at point P. So let me take this B at point P. So out of these two, which is bigger? Mu naught I is same in numerator, but denominator this is big. So this will be smaller and this will be bigger. So B coil minus B wire. So this is mu naught I by 2r minus mu naught I by 2 pi r mu naught I by 2 pi r pi minus 1. So this is mu naught I by 2 pi r pi minus 1. Option 1 is correct. A coil of area, this is the area of the coil with the number of turns n carrying a current this much. If coil is placed in a field of 400 Nm per Tesla with normal to the plane of the coil making angle 30, then what is couple felt by this one? Couple or torque is given by BIAN sin theta if normal makes an angle theta with field. Normal makes a theta angle with field. But torque tau is equal to BIAN cos theta if plane of coil makes an angle theta with the field. Be careful with this plane as well as normal, but in this problem it is a normal. So let me use the first formula. So the torque is given by BIAN sin theta. The magnetic field is 4 into 10 power minus 5. The current is 0.5, let me take it as half. Area 2 into 10 power minus 2. Number of turns this, and sin 30 1 by 2. This 2 and 2 get cancelled. This 2 and 2 get cancelled. This is 2 into 10 power minus 2 plus 2 cancels, minus 5. So the answer is 2 into minus 5 Newton meter. A straight conductor of length L is bent in the form of a circle. Its ends are joined and a current of 1 ampere is passed. What is the magnetic moment? The magnetic moment of a coil is given by NIA, that are number of turns, but here a straight wire is joined with their ends into the bent in the form of a circle. Now, how much current is passing here? Number of turns are 1. Current is given as I, that is 1 ampere, and area. So how to find this area? The length is given. So length is equal to 2 pi r. So this is area is pi r square. So in place of r you can write L by 2 pi. So this will be 1 into 1 pi into r is equal to L by 2 pi. R square is equal to L square by 4 pi square. One of the pi will cancel. This is L square by 4 pi. So the option 2 is correct here. A straight conductor carrying a current of 1.5 present in uniform magnetic field of this much in a direction perpendicular to the field, that is theta is 90, then force expression of the 0.2 meter length of the wire is. We know this formula, F is equal to Bill sin theta. Magnetic field is 5 into 10 power minus 2. The amount of current is 3 by 2. 1.5 I am writing as 3 by 2. Length of the wire is 0.2, that I am writing is 2 by 10. And sin 90. This 2 and 2 get cancelled. 5 ones and 5 2. So 3 by 2 is 1.5 into minus 2, 10 power minus 2, sin 90 is 1. So the answer is 1.5, 0.015. Option 3 is correct. 12th one, two parallel wires of 10 centimeters apart attract with each other force of 10 power minus 5. These are the two parallel wires, 10 centimeter apart. This distance is 10 centimeter apart, carrying some current, and they are attracting with a force of F is equal to 10 power minus 5 Newton per meter. That means they are repetitive wires. For every 1 meter, they are attracted with the force of this much. Current in one of the wire is 10 amperes, and then the current in the other one is dash. Here, if these two are attracting, the fields due to these two must be in opposite direction. That means current in this direction, I2, which is acting in the same direction. If current is flowing in same direction, they attracts. If they are acting in opposite direction, they repulse with each other. So here, the force per unit length is equal to mu naught I1 I2 by 2 pi r. This is given as 10 power minus 5. This is 4 pi into 10 power minus 7. The first current is 10. The second current we are finding 2 pi into distance between these two is 10 centimeter or 10 power minus 1 meter. 2 pi 1s and 2 pi 2s. So this will be 10 power minus 2. This will become 10 power minus 6. This will become 10 power minus 5 is equal 2 into 10 power minus 6 I2 by 10 power minus 1. This will go this side. This everything get cancelled. I2 will be 1 by 2. So 0.5 correct. 13. A horizontal wire of length 0.05 meters. So length of this one is 0.05 meters. Carries a current of 0.5 amperes. If the mass of the wire is 10 milligrams, the magnetic field required to support the weight of this wire. That means without any support, it should be in air. So for this to hang in air, so if you send some more current in another wire in the same direction, these two will attract with each other. That means attractive force will act upwards and the weight of this wire will act downwards. If these two are equal and opposite, without support also we can keep this wire in air. So now, what is the attractive force? Attractive force must be equal to weight of this body. Attractive force is given by mu naught I1 I2 by 2 pi r, that is for L length, is equal to mg. In this we need to find out the strength of the magnetic field. So that is here, if F attractive is given, this can also be written as this is the magnetic field due to the first wire at this point at a distance r. So this is B IL is equal to mg. So B can be written as mg by IL. What is the mass of this body or wire? 10 milligrams. So 10 into grams means 10 power minus 3, milligrams means 10 power minus 6. G it is not given, actually it is given as 10. So you can take it as 10 by current in this conductor is, one of the conductor is 5 and length of the wire is 0.05 meter, 5 into 10 power minus 2. So this will be 10 power minus 4 by 25 into 10 power minus 2. When these two get cancelled, 10 power minus 2 by 25. So this will be 100 by 25 into 10 power minus 4. So 4 into 10 power minus 4 Tesla. So answer is option 1 is correct. 14. The velocity of a proton traveling in a curved path in the magnetic field is V. So when a charge enters into a magnetic field, let us say this is a magnetic field which is acting into the board. If a charge enters here, according to Fleming's left hand rule, if it is the field, if it is the charge, it will experience a force downwards. So if the magnetic field exists here, so for this charge here, the field is acting into this one, charge is entering like this, and the force will be experienced by this charge in the upward direction. So this will move in the circular path. So who is providing the centripetal force for this charge to move in a circular path? That is nothing but the magnetic field. So F is equal to mv square by r. F we know, F is equal to BQ is sin theta, theta is 90. This is mv square by r. These two get cancelled. R is equal to mv by BQ, the radius of circular path. From this we can write V is equal to BQR by m. In this problem, the velocity of proton is given. What is the velocity of alpha particle in the same magnetic field? So velocity V is equal to BQ BQR by M. So this is V proton is equal to BQ proton radius by M by V alpha is equal to BQR by M alpha. This is M proton. This is B alpha B proton. Now, as these are traveling in same magnetic field in the same curved path. Same curved path means the radius is also same. So you can cancel R and R here. So what are the remaining terms here? So Q of proton is, let me take it as Q, and the mass of proton, let me take it as M. Then this will become Q alpha by M alpha. So mass of alpha is 4m, as alpha contains 2 protons and 2 neutrons, and the charge is equal to 2q. Only protons will have charge and neutrons have no charge. So QQ get cancelled, MM get cancelled, this become 2:1. The velocity of proton in this problem is given as V. So V by V alpha is equal to by V. So V alpha is equal to V by 2. So option 4 is correct. An electron enters into a region of uniform magnetic field of induction this much, B, at right angle with the velocity this much, V, it gets into circular arc. Radius of the circular path is given by R is equal to mv by bq. We know that mass of electron is 9.1 into 10 power minus 31. It is having a velocity of 2 in 10 power 8. B value 9.1 into 10 power minus 5, and a charge of electron 1.6 into 10 power minus 19. You can see this 9.2, 9.8 cancels. So this is a 2.4 into 10 power minus 23 by, this will be 1.6 into 10 power minus 24. So this will be 0.82, so 0.83. So this is 1.5 into 10 power 1. So this is a 15 meters. Option 1 is correct. A galvanometer shunted with a 1 ohm resistance. 1% of the main current has to pass through it. Resistance of the galvanometer is. So the resistance, the shunt is given by capital G by n minus 1. S is equal to G by the maximum current or the main current by current to the galvanometer minus 1. Here only 1% current has to go. So let us say this is 100, this will become 1. S is equal to G by 100 by 1 minus 1, that is G by 99. They are asked to find out the resistance of the galvanometer, that is G. G is equal to 99 into S. The shunt resistance is 1 ohm. So this is 99 ohms. Option 3 is correct. 17. A voltmeter of range 0 to 10 volts has a resistance of 1000 ohms. It can be converted to ammeter of range 0 to 10. This is 0 to 10 by connecting this much. So first a voltmeter is given. The voltmeter range is 0 to 10 volts here. That means it can measure a maximum voltage of 10, and resistance of this one is 1000 ohms. So what is the current that can be passed through this one? This is going by V by R. That is V is equal to 10, R is equal to 1000. So this will be 10 power minus 2 amperes. Now I want to convert this into ammeter which can measure up to 10 amperes current. So what is the resistance of the shunt that be connected? G by n minus 1. This is G is equal to, that is nothing but resistance of the galvanometer, which is 1000 initially. Now I want to measure 10 amperes, that is main current is 10, and the least current that can be measured by using this one is 10 power minus 2 minus 1. So S is equal, this is 1000 by, this 10 will go up 10, that means 1000 minus 1, this is 99. So you can see this one, 99 means 100, nearly this is equal to 10 ohms in parallel. Option 2 is correct. A moving coil galvanometer of 50 ohms, resistance give full deflection when current is this much. So resistance of moving coil galvanometer is 50 ohms. Current through this one is 0.5 milli, that is 10 power minus 3 amperes. To convert into a voltmeter of 10 volts, that is voltage 10 volts, resistance to connect in series with this one. So R is equal to V by Ig minus G. The voltage to be measured is 10. Current through this one is 0.5 into 10 power minus 3 minus G is 50. So this will go up 10 power 4. So this is 10 power 4 by, this is 1 by 2, that is 2 in 10 power minus 4 minus 15. So this will be 20,000 minus 15, 90,950 ohms. Option 3 is correct. Two electrons describe circles of radius 2 and 3 centimeters in same magnetic field. So this is a first electron which is circling in a radius, circular path of radius 2 centimeter, and this is R1 and this is R2, which is equal to 3 centimeters. In the same magnetic field, that is B1 and B2, that means magnetic field for these two electrons, E1 and E2 are same. What is the ratio of the kinetic energies? The kinetic energy is given by Ke is equal half mv square, that is half m into, we know this formula, R is equal to mv by bq, v is equal to bqr by m. So v can be written as bqr by m whole square. So kinetic energy of a charged particle is given by p square q square r square by m square, and m get cancelled. This will become b square q square r square by 2m. Now, as they are moving in same electric magnetic field with the same charge and same mass, kinetic energy directly proportional to square of the radius. So here R1 is this, R2 is this. So what is Ke1 by Ke2? This is R1 by R2 whole square. What is R1 here? R1 is 2 centimeter, R3 is 3 centimeter. So 2 by 3 whole square. This is 4:9. Option 3 is correct. A cylindrical cavity of diameter small a exists in a cylinder of radius 2a. So this is a cylinder of this diameter 2a. So radius of this one is a only. Now in that we have a cavity like this. This is the white color one is a cavity. Now a uniform current density J flows through along the length. If the magnitude of the magnetic field at point P, at this point P is given as n by 12 mu naught a. So the total magnetic field is n by 12 mu naught into a, then Aj, that is J is the current density. Now what is n value? So here 5, 6, 7, 8. Now here if you want to find out magnetic field due to this cylinder, so let me take one circular path here. So what is the magnetic field here? From Ampere circuit law, B bar dot dl bar is equal to mu naught times the current enclosed by this one. So at point P, due to cylinder, this will be B integral dl bar is equal to mu naught into current density J is equal to I by A. So I is equal to J into, what is the area of this one? Radius A, this is pi A square. So let me write this as a J pi A square. Now, this is a B into, what is the circumference circular path here? This is as the radius is A, the circumference is 2 pi A. So this is 2 pi A is equal mu naught J pi A square. This pi and pi get cancelled, A and A get cancelled. Magnetic field due to cylinder, this is due to cylinder, is given by mu naught J A by 2. This is equation 1. So this is magnetic field due to the entire cylinder. Now due to cavity, that is also in the form of cylinder. So B due to cavity integral dl bar is equal to mu naught times the current through that cavity. So to find out the field at this point P due to this one, you have to construct one circular path here whose radius is from here to here A, this is A by 2. So the radius of this one is 3A by 2. So now what we are going to write, B cavity into circumference of the circular path around that cavity is given by dl is 2 pi 3A by 2 is equal to mu naught into, what is the current through that small circular cavity, that is I is equal current density into area, that is current density. What is area of that one? Here radius is A by 2 only. So pi A by 2 whole square pi A square by 4. Now you can cancel this pi and pi here, this A and A here. So this will be B cavity will be mu naught J A by this 2 to get cancelled here, 4 3s are 12. This is equation 2. But they have given that the net magnetic field at that point P is given as mu naught by 12 mu naught n into Aj. So now what is the net magnetic field? That is B cylinder minus B cavity, because the cavity is removed there. So now we can write this as mu naught J A by 2 minus, this is mu naught J by 2, this is mu naught J A by 12. So LCM is 12, 2, 6, this is 6 minus 1, 5 mu naught J A. Now you can compare this one, 12 and 12 same, mu naught AJ, mu naught AJ. So N must be equal to 5. First option is correct. 21. A coil having N turns is wound tightly in the form of a spiral with inner and outer radii A and B. So this is a spiral and it is wound like this such that the inner radius is A, the outer radius is B, with the total number of turns in this one are N. When the current I passes through the coil, find the magnetic field at the center. To find out the magnetic field at the center at this point, and as this there are N turns in the space. This space is this is B, this is A, in B minus A space, that is B minus A meters distance. So in 1 meter distance, the number of turns will be N by B minus A. Now let me take a small cylindrical strip here, which is a distance of R with thickness dr. So let us say in this the number of turns are dn. So in dr meter distance, the number of turns will be N by B minus A into dr. So here I am multiplying this with dr on both sides. Now what is the magnetic field due to the small circular strip? So that I will take it as dB. dB is given by mu naught dn current I, which is given as capital I, by 2r. What is the r? Radius of this one, r. So dB it can be written as mu naught by 2r. What is dn? That is, these are the number of turns, small number of turns, this much. So this will be N by B minus A into dr into I. To find out the total field, integrate on both sides, here with 0 to B, here with number, this one A and B. So integral dB is B. So this is B will be mu naught constant, 2 constant, total number of turns constant, B minus A and I are also constant, integral dr by r with limits A to B. So this is mu naught Ni by 2 into B minus A. Integral dr by r is log r. So log r is r, these values are A with B. So the final answer is mu naught Ni by 2b minus a. Log bigger value by smaller, that is log b minus log a can be written as log b by a. So log natural b by a. Option 3 is correct. So an infinitely long hollow conducting sphere cylinder with inner radius r and outer radius capital R. So this is a cylinder. The inner radius is r by 2. The outer radius is r. Carries a uniform current density along its length. So this is a cylinder. So this is this. That means it is a hollow cylinder like this. Now, the magnitude of the magnetic field B as a function of its radial distance from R axis is best represented as. Now see, at the center, if you want to find this one, you consider one Amperian loop here. If you take Amperian loop here, there is no current within this Amperian loop because current is passing only through this solid surface. So as there is no current here, no field will be produced. Till this R by 2 there is no current. That means no current means no field, because B integral dl bar is equal to mu naught times the current enclosed by this Amperian loop. So as there is no current enclosed within this space, so till R by 2 current will be 0. So here current is there, field is there, so this is wrong. Here up to R by 2 no field, so it may be correct, this may be correct, this may be correct. Next, as we move away from this one, from here to here, if you take one ampere loop, current slowly increases. So it increases, B is equal to mu naught I by dl, inversely proportional. So here this is not constant, so this is wrong, and it is not directly proportional, so this is inversely proportional. So graph will be option 4 is correct. After this one, away from this one, and as these are inversely proportional, it gradually decreases. So option 4 is correct.